more than even normal. So we are on our last section, section 9.5, solving linear differential equations. So what does a linear differential equation even look like? It will have a derivative on its own, plus a function of x times a single y equals another different function of x. Or it might be written as y dash, the same thing. And that is a linear differential equation. That's the form, that's the shape that they have. Now, to solve a linear differential equation, there is actually a formula for it. It's this formula here. It's quite a complicated formula because it involves integrating things. So it's 1 over a guy called I of x times the integral of I of x times q of x dx plus c. This thing called I of x is given the name the integration factor, and I of x is e to the integral of p of x dx. So you see there's lots of bits to it. Essentially what you do, and this is the 3 main stages. Step 1, convert your differential equation to look like this. Now in a lot of questions, hopefully it'll already be converted and it'll look like that, so you don't need to do anything. But let's say, in this case, let's say that you didn't get it that format, you should write it like this. The next thing you do is you find the integrating factor, which is this fella. And the last part is you put all the pieces into this formula and you integrate. So you are going to do some integration, right? You're going to do some integration to find I of x. And then later on, you're going to integrate this guy. So let's jump straight in and show you what that looks like. This is question 1. And we have y dashed, take away y, equals 3e to the x. Do I have a derivative on its own? Yes, I do. That means that I can now identify that the p of x is -1 and that the guy that's going to be called q of x is that guy. Are we comfortable with who p of x is and who q of x is? P of x is the thing next to the y, q of x is the guy over here on his own. So that's essentially step 1 done. Wasn't really that much. Now in step 2, we're going to find the integrating factor, this guy called I of x. It's e to the power of the integral of p. So it's going to be e the integral of -1 dx. And the integral of that guy is just -x. Now you might be thinking, what am I going to do with all these plus c's that happen when you do indefinite integrals? Don't worry about them. That 1 plus c takes care of them all. So that's just e to the -x, right? It isn't e to the -x plus a c or anything, right? It's just e to the -x. And that's step 2 done. So now we find the solution. It's 1 over I of x, the integral of I of x times q of x dx, I'd say. Now, how's that guy going to work out? Well, let's find out. One over e to the -x. No big deal. The integral of I of x times q of x dx, I'd say. Now, we should start thinking about style points here, right? Making things look pretty. Let's focus on just this little guy here. 1 over e to the -x is not a very nice way of writing that? Would you agree you could write it a better way? What would 1 over e to the negative x look like if you did it in a different form?
E to the x.
E to the x.
Right, perfect. Two of you at the same time. Isn't that the negative power on the bottom is the same as its positive power on the top, right? We've done this up and down, top to bottom, bottom to top in other situations. Now, what does e to the negative x times an e to the x get you?
1.
So that's just 3 times 1, which is 3. So have you seen that this has now simplified quite a bit? It's now 3. Now the integral of 3 is just 3x. And if I distribute the thing, you get that. We've just found our general solution to our differential equation. And as far as I'm concerned, those are identical. They're just different versions. Maybe somebody tomorrow will tell me that WebAssign is happy with both versions, or that WebAssign only wants the bottom one, or WebAssign only wants the top one. I guess you'll find out when you do some, probably in the first question. But both of those are correct, right? We agree that is this. As far as style points go, my brain kind of likes this a little bit better than that, but there are some circumstances where maybe writing it out would be a bit more helpful than keeping it as 2 things multiplied. Is there anything about that particular one? That's a very straightforward one, right? Nothing too weird going on. Are we cool with that one? Any questions? I'm moving on. Right. Oops. See who my next one's going to be. Oh. Who do I want? Who do I want? Yeah, I want this one. Oops. There, I fixed it. This is going to become that guy. But he isn't that guy right now. Do you notice that the major issue is y dashed, right? The derivative. It's not on its own. So when you look at these questions, find that guy first and figure out how to make him on his own. Would you agree the job here is get rid of that x? Now, if I wanted to get rid of that x, shouldn't I divide everybody by x? Now, if you divide this guy by x, you get that guy. If you divide this guy by x, I'm going to write it like that. I could have written it as y over x, right? But I'm going to write it as 1 over x, y. And the reason I want to do it that way is, don't I have to identify who the p and the q are? And it's going to be a little bit easier if I write it that way. Now, the weirdest one is going to be this guy. Technically speaking, I have to divide it by x, right? Totally agree with that. But don't we also want it to be written in a format that's going to make it easy to integrate later? So I'm not really going to leave the square root alone. I'm going to call it x to the half. Now, if you take this guy and this guy, is it okay for me to do 12x to the negative half? Do you understand where I got that from? Right. And I am not going to call that 1 over the square root of x or anything like that, because in this format, isn't it ready to be integrated if it needs to be? Now, in this format then, we now can write down who P of X is. He's 1 over X. And who Q of X is. And Q of X is that guy. So that's step 1 done. Let's do step 2 now. Integration factor is E, the integral of Px dx. E, the integral of 1 over X dx. And 1 over X is the natural log of X. Now think style points. Make things look as pretty as possible. E to the power of the natural log of X actually simplifies really nicely. E to the power of the natural log of X. Right? What do you get?
X.
Step 2 is finished. Step 3 coming up. Well, the solution is 1 over I of X, the integral of I of X, Q of X, dx, plus a C. 1 over X, the integral of X, 12X to the negative a half, plus C. If you multiply these together, you get 12X to the half. Are you comfortable with that times that being this? Are you okay with what I did? I just basically added 1 and negative a half together. Now, this guy is ready to integrate. So let's see what we get. Add 1 to the power. Divide by the new power. Well, that's the same as multiplying by 2/3. But 2/3 is 24/3. So that ends up being 8. Okay, that's not too bad. Add C. I think this question, style point wise, would benefit by multiplying both of these by 1 over X. So that is the solution. If you distribute this, 1 over X times that basically takes a half power off. And 1 over X times that guy is C over X. And I don't like half powers. It looks like we now have three different versions, only in the way they look. They're identical mathematically, but three different versions of the solution, the general solution. Actually, I just thought of a fourth one. Technically, isn't that also correct? Good luck with WebAssign. I hope any one of those four would be accepted. At least 2 or 3 out of the 4 would be, I'd live with that. If they only want 1 out of that 4, will you try and learn from the one that it wants what it looks like for the next question, so you don't have to keep doing different versions of it each time until you get the one it's looking for. The best answer would be any of those work and it's happy. That would be the best world, wouldn't it? In which case you don't really need to work. Me personally, as far as style points go, I think the third one's the prettiest. Right? I guess it's a value judgment. Do you think different from me? It's fine, right? But I like that one. Why do I like that one? Well, we haven't got it, but do you know that we're going to do questions where there's a boundary condition, where we're going to find C. And I think this form's going to make it easy when X is 4 or 2 or 17 to find out who C is. If you start using fractional powers or negative powers, doesn't it just get a little bit messier when you do the calculation? Because then you're going to have to do 2 to the power of -1, and you might not. Or God forbid, 3 halves to the power of -1, right? Something really yucky, and it might throw you a bit. Same question as before. Are we good with this? Right. So let's see if we can take it to the next level. I don't know what one I want to do. I'm just scanning through them, seeing if anything strikes me as being interesting enough to. Yeah, why not? Question 5. I basically picked that one because it struck me as being really, really ugly. Secondly, it looks like it's going to involve a little bit of changing, right? Would you agree the derivative is not on its own? If you fix that, the rest kind of come. Which means I'm going to have to divide everybody by this. Not very nice. So what's that going to get me? dr by dt on its own plus 1 over t natural log of tr. Do you see how I did the same thing I did last time? I just called it 1 over so that I could separate this. And then it's going to equal, well, essentially 5t e to the t over t natural log of t. Now that I've written that down, I realize I can cancel. So I shall do that. And I get that. That's not looking pretty, is it? That is not looking good. But trust me, because I can see the answer in front of me, right? It does come out nicer. In this question then, x is a t essentially. So p of t is going to be 1 over t natural log of t. And q of t is going to be this guy here. Oh, this is going to be fun, isn't it? So step 2. Let's get the integrating factor. E to the integral of p. E, the integral of 1 over t natural log of t dt. Now, as the questions get more advanced, we sometimes have to kind of pause and take something like this and do it as working on the side. And once I get the answer, I'll just fill it in here. Otherwise, aren't I going to have to write a whole load of e to this, e to this, e to this, and it just won't look pretty. So right now I'm just focusing on integrating this guy. It's really one of two choices. It's a U sub or it's an integration by parts. I don't think it's anything else. Oh, excuse me.
I think it's U sub.
I think you're right. And when you do a U sub, you have to decide who the U sub is.
ln of t.
ln of t.
Agreed? Now, what's that going to get me? Well, when I differentiate with respect to t, I'm going to have 1 over t. And when I do the crossover, oh, I'm finished. Right? I know what dt is. So this is going to be 1 over t u times t du, which is, because the t's cancel, 1 over u du, which becomes the natural log of u, which becomes, wait for it, the natural log of the natural log of t. Now that's pretty weird. So this fella here is e to the natural log of the natural log of t. Now you better have your thinking cap on. Style points. What the heck does that become?
Natural log of t.
I'm hearing a lot of NLTs. Good, because that's exactly what it is. See if that was e to the natural log of 42, wouldn't the answer be 42? E to the natural log of t cubed, wouldn't it be t cubed, right? Essentially, the natural log and exponential functions are inverse functions and cancel each other out. So you end up with whatever's here. Well, that's good. Moving on then to step 3. We get our solution. Well, it's not y equals, it's going to be r equals, because r is like the y, right, and t is like the x. And that's going to be 1 over I of t, the integral of I of t, q of t, dt, I'd c. So that's going to be 1 over the natural log of t, the integral of the natural log of t, can't find my guy. Here he is. Q of t. They cancel. Now, what was a worry has now disappeared. I mean, when you look at these two, there should have been a bit of apprehension, like, oh God, what's this going to look like? But look, it's not bad at all. So we have this fella. That's just basically 5e to the t plus c. And that's one version of the answer. I'm not going to go through every combination I can think of this time. There's a couple of versions of what it might look like. Oh, I just had to look at the answer. That's the one they've got. Now, that doesn't mean they won't use these two, so you might be okay. But that's the one that they wanted. And it makes sense because they do share a common denominator. Are we learning cool stuff today or what? I mean, this is integration, algebra, style points. I mean, it's a bit of everything, isn't it? Is question 6 good to go? Do I need to do anything, or is it ready? It's already a linear differential equation.
Good to
Good to
go.
go? Okay, agreed. P of x is 5. Q of x. Are you not a little bit worried about Q? It looks kind of scary, doesn't it? Because you know you're going to integrate this, or at least this and stuff with it, right? It's going to come out fine. Oops, don't know where that came from. It's going to be e to the integral of 5. Well, nobody should complain about that guy, right? That was easy. So let's get right into the heavy duty stuff. I'm going to do two things at once. I'm going to put the 3 there. Okay, look at this integral. That's the guy that we need to get, right? Look at it with fresh eyes. What method will I use to solve this fella?
U sub
Yeah. Who's the u sub?
e to the 5x.
Can you trust me that you get, I think it's 3/5 sine u, comes out pretty nicely. You probably want to do that as a piece of paper at the side working. I'm just going to go ... right, and you would finish it in the usual way. What else we got? Have I done a question where we needed to do integration by parts? Have we seen one? Okay, so let me go hunting for one that has an integration by parts on it. You know, you can never find things. Yeah, this one. Well, I can see this one's going to be integration by parts. Yes, it is. We should really set up step 1. This guy is not quite right. Shouldn't the y be next to the derivative? And it's over here. So I'm just going to add y to both sides. Not much of a fix, but we needed it. P of x is 1, and Q of x is 6x. That doesn't look too bad. integration factor e to the integral of p, e to the integral of 1. Well, that's not bad. The integrating factor is just e to the x. Step 3 then. Y equals 1 over I to the x, the integral I of x, q of x, I to c. And I of x is ex. And ex times qx, if I rewrite them in a slightly different order, I'd c. Do you now see an integration by parts situation? Great. Now, if that was 6x e to the power of x squared, I mean, it could have been, right? If it had been 6x e to the power of x squared, wouldn't it have been a u sub question? And it would have been u equals x squared, right? But it's a 6x and an e to the x. Sometimes they look very similar, right? An integration by parts looks like it might be a u sub, right? Kind of might be, but it isn't in this case. Since it is integration by parts, I should do the working at the side. And then once I'm finished, I'll write it in here. Okay, I need an F, I need a G.
Six x as g, and d to the x as f.
Right. For those who are looking at that answer, it's correct. That's the only version that works, right? So it could be I just guessed, but I don't think that's the case. Why do you know that's the right one? Maybe you've just done so many, your brain tells you.
You want to make G the one that doesn't change when you integrate. Or changes the least.
Okay, or is doable as well. If you reverse that, don't you want F to get simpler when you differentiate it? Which is kind of saying what you're saying, but from a different perspective. Right. So that guy, when you differentiate him, is going to be 6. And this guy, oops, when you integrate him, doesn't change. Right. At least he doesn't get uglier, right? So we have integration by parts, which is f of g, take away the integral of f dashed of g. Leave that alone, integrate ex, take away, differentiate 6x, integrate e to the x, and we are left with that guy. So in here, I'm going to go 6x e to the x, take away 6 e to the x. And I think it would be a good idea to multiply through. This guy times this guy gets me 6x. This guy times this guy gets me -6. And this guy times this guy gets me c over e to the x. Of course, knowing Weber sign, they may write it like that. And now that I'm looking, they write it like that. But that's the same thing, right? So we've seen one where you needed to do a U sub. We've seen one now where you need to do an integration by parts. The other ones were just power rules, right? So they weren't too difficult. That's the major kinds of questions done. So let me see if I can find one last one to do for today. And all the good ones are used up. Oh, here's one. Oops, that's a plus. Oh, excuse me. I scanned. And I shouldn't scan, but I scanned wrongly. It says cos xy. That's not good. Agreed? That's not good. Okay, it's not ready yet. It needs to be written in its proper form. That sin x has to leave the building, which is kind of where my earlier mistake came from. If you divide everybody by sin x, you get that. Which really is very scary. Have a look at Q of x. Doesn't look good. Agreed? Have a look at P of x as well. Well, P of x is a cosine over a sine. Q of x is basically that horrible mess. Let's do step 2. The integrating factor what's that? I'm going to find out what that guy is over here. What method do you think I'm going to use to integrate this guy?
A U sub,
Who's the U sub?
sine.
Yeah. And that gets you, when you differentiate it, cosine, crossover, 1 over cosine x. I know it's only 11 weeks, but shouldn't U subs become almost second nature now? Yeah, you know the process. Now, what's going to happen here is, at least originally, cosine x over U times 1 over cosine x du. That becomes 1 over U, and we get the natural log of U, which becomes the natural log of sine x. And that's what goes here. And then we look at style points. Well, this happens quite a lot, doesn't it? Because you end up with e to the power of everything when you do ix. And e to the power of the natural log of sine x is simply just what?
Sin x.
Sine x.
Yep, agreed. So we're now on to our final step. Y, the solution, is 1 over I of x, the integral of ix qx plus c. 1 over sine x the integral of sine x times this, which is 8 sine x squared over sine x dx, add c. These cancel, and you're left with 8 the sine of x squared dx, add c. Which isn't actually that bad, because this question is one of those questions where it says, here are 7 or 5, it's 5 answers, which one is it? And this one happens to be, in my solution, happens to be the 5th circle. So you just scan through all the ones so you find the one that looks like this guy. So you
forgot
don't
the
add.
integral sign.
Oh, yeah. Well caught. So you go through that one until you find the one you want.